Welcome back. This is Mr. Neal, and we're going to look at the last two shapes of position versus time graphs that you will need to convert into velocity versus time graphs. So the first of these two shapes, they're both going to be curves, but the first curve looks like this one. And this curve represents an increasing velocity. So it starts out at some low value and it gets higher and it gets higher and it gets higher with every passing second. It's very easy to prove that this is so. Let's pick a color. Let's use blue here for our first point. I'm going to sketch in a blue line which represents the slope at this first position, and this will be our velocity at position 1. Let's choose a second color. Let's go with red here so it contrasts quite nicely, and sketch in the slope of our second position. This represents the velocity at time 2. You can see it's very clear that the velocity at position 2 is greater than the velocity at position 1. So our velocity is indeed increasing over time. So if I want to transfer this to a velocity versus time graph, I'm still graphing slopes, but my slopes are no longer constant. I have this first slope for the initial velocity and the second slope for the final velocity. And it's increasing. So how do I show this? I show this with a positively sloped line. Now, we already know, probably, I assume, the colloquial word for getting faster, and that is accelerate, or acceleration. This first graph represents positive acceleration. Indeed, both of these graphs represent positive acceleration. We are starting at some low velocity and it's getting faster. Our velocity is increasing over a period of time. Now, there is a second case. Let's choose a different color that stands out from this yellow. And this second case takes our position versus time graph, like so, but the curve is in the opposite direction. So again, let's pick two different points on this graph and use, whoops, that's too steep there, two different colors to represent our positions. So this is position 1, and this is its velocity at position 1. Again, let's switch to, let's say, red for this one. At position 2, its velocity will correspond to this red line. Velocity at position 2. Now, unlike the first graph, we have a decreasing slope, so it's pretty obvious here that our velocity is going to be falling on this graph. And indeed, when we come over to this graph and plot it, we're going to wind up with a negative slope. This one is getting slower. Colloquially, we would refer to this as deceleration. And indeed, I'll use this word, physicists will use this word, it gets thrown around. But the actual term for this is not deceleration, it is negative acceleration. And the reason for this is one of the things that I will go over in the video that describes what acceleration actually is. But these are the last two shapes that you need in order to convert any position time graph into a velocity versus time graph.